So next we are going for third generation architecture. Under the third generation architecture, we'll be having that pave pillar type architecture. So why we go for pave pillar? So pave pillar is a USAF, United States Aircraft Force System, which programmed to define the requirements and avionic architecture for fighter aircraft of the year in the year 1990. The program emphasizes under the pave pillar or here pave pillar will have increased information fusion, higher level and complexity of software, standardization of maintenance simplification, lower cost, backward and growth capability while making use of emerging technology, BHSIC, voice recognition and synthesis and artificial intelligence, TGA, that is third generation architecture, will provide capability for rapid flow of data in, through and from the system as well as between and within the system. Higher level of avionic integration and resource sharing of sensor and computational capability is possible. Pilot plays the role of a weapon system manager as opposed to the subsystem operator as well as information integrator. It is able to sustain operation with minimal support, fly successful mission day and night in any type of weather. It will be able to face a numerically and technologically advanced enemy aircraft and also defensive system. This is the pay pillar advantages. Here it is able to sustain, that is sustainability is very high, effectiveness also very high, lower LCC. These are the advantages of pay pillar. So pay pillar architecture will hold all this point. Component reliability gain, use of redundancy and resource sharing is possible, application of fault tolerance, reduction of maintenance test and repair time, increasing crew station automation, enhancing stealth operation, wide use of common module, that is HW and SW, ability to perform in aircraft test and maintenance of avionics. Here the use of VHSIC technology is possible, and then it is capable to operate over extended periods of time at a austere deployed location and be maintainable without the avionic intermediate SOP. Then a modularity concept, which will be cutting down the cost of the avionic related to the VMS, mission processing, PVI and SMS. The sensor cost account for 70% of the avionic cost. USAF initiated a study project to cut down the cost of sensor used in the fighter aircraft. In 1990, Wright Laboratory, MC Donnell Aircraft, Boeing Aircraft Company, and Lockheed launched the PACE program. Come with the concept of integrated sensor system. PACE takes pillar as a baseline in standard. The integration concept extends to the skin of the aircraft, integration of the RF and EVO sensor, originally designed for Joint Strike Fighter JSF. This is the PACE block diagram. Here you'll be having integrated RF sensing, code processing, EVO sensing, vehicle management, store management, vehicle interfacing for pilot. Everything will be integrated here. That's why it's have more advantages than other architecture. Avionics system evolution. So independent avionics in the year 1940 to 50 developed. Federated avionics was developed during the year 60 to 70. Common integrated processor was developed during the year 1980 to 1990. Then advanced integrated avionics are developed after the year 2000 or represented in this diagram. So some few keys which are noted in the avionic architectural evolution are increased digitization of function, increased sharing and modularization of function, integration sharing concept increased to the skin of the aircraft. Functionality has increasingly obtained through software, complex hardware architecture module, complex software module, increased network complexity and speed.